yesterday when we did day one of correlation and causation, again, we're talking about how the two variables correlate, the input and the output kind of thing, or the explanatory and the response variable. But one thing we should probably, and I probably should have talked about yesterday, but we'll just put it in today's, is when you have two variables like that, it's sometimes called bivariate, meaning they are both varying, right? X and Y change as you go. If you look at the words, sometimes they're a little less scary, right? Or what some people call it is how they are associated with each other, okay? And whenever two variables are associated, like X and Y, as things go up, maybe they both go up, maybe they both go down, who knows, right? And you have to take a look. But whenever you're going to talk about those, and you can look at them in scatter plots and things like we did yesterday, but there's three main things that you're going to want to discuss when you have something like that. So I'm just going to add a page in here. So when you have association, and you can just put this on today's notes or wherever you want to put it. When you have association, there's three things that really you should talk about. So put it at the top of this notes, get out yesterday's, throw it on there, whatever you want to do. And they're pretty straightforward. It's really not that hard. The first thing you should definitely talk about if you're going to describe it is the direction. And we actually talked about that yesterday, right? What do I mean by direction? What were some of the things that maybe we used yesterday? Positive, negative, exactly. Those are some of your ideas of how you could talk about the direction, okay? Or a positive correlation, right? Correlation and association, you see how those are kind of the same word. They can go back and forth, okay? And then another thing you should talk about is the strength. Well, what do we mean by strength? Well, how good does it align to how you want it to align? A lot of times in here we are going to talk about linear, right? We want it to be aligned, but it doesn't have to be. We talked about that yesterday. You could have one that looks like a parabola, right? How strong does it follow that? So is it a weak, or so some of the words you could use is it's a weak linear maybe, or a moderate would be another way you could put it. Or obviously if you've got weak, you'd have to have also strong, right? And that would be, boy, you're sitting there and they just go right up in a line, right? That's a pretty strong correlation or association, okay? And then one that, a lot of times gets skipped at this level but we didn't, is the form. In other words, what does it look like? Well, what's the one that we're most concerned with right now is if it's linear, that would be the form, right? Or we even talked about it kind of looks maybe curved, you could say, right? That's how some people might call it. Instead of a parabola, they might use the word curved, or even nonlinear, right? These are all words you could use. So form, you could say linear, or maybe you would say not linear, or maybe even say curved. The reason I'm focusing a lot on this is as I looked at the results from last year's AP, this was very important to them. It seemed like it was only one part of one of the questions they gave, but they actually counted it as 3 of the 4 places they actually scored. Each one of these had its own point value. And so I thought that maybe we should really make it very specific to make sure that if you are planning on discussing any of these or taking the AP, that when you are talking about association or correlation, you got to talk about direction. Is it positive? Is it negative? How strong is it? And then what's it looking like? Is it looking linear? Is it not linear? And how that goes. Okay? So is everybody clear on that? Okay. So I'm not sure where today's, oh, here we go. So one of the things that actually is going to help us talk about some of that, and again, correlation using a scatter plot can sometimes be a little subjective though. One of you might think it's a strong correlation, right? And one might think, it's moderate, right? You see what I mean? How that could have its own little interpretation from each of you, correct? And so that's why we have something that's going to help us out. It's a value. You can't dispute a value if you calculate it right. Agreed? You're all going to be looking at the same value, and it's going to mean something. And that's called the correlation coefficient. Correlation, again, means how do they associate. Coefficient is, a lot of times you think of that as the number out front of a variable or something like that. But it really is going to stand for, how strong does that data go in there. And whoops, I'm looking at the wrong one here. And here's really what it stands for. A measure of the strength and the direction. Well, there you go, right away, right? 2 of the 3 that we talked about, right? And I haven't even got barely started in this thing. Strength and direction of a linear relationship. So there they are right there. Strength, direction, form. Okay, so correlation coefficient is usually used in our cases here, a linear relationship. You can actually calculate it for the other ones as well. But for our purposes, it's going to be linear. And it's, again, between two variables. Normally we call them x and y, right? But they don't have to be. The symbol r represents the sample correlation coefficient. Okay. From what I've seen on the AP, if they actually want you to calculate correlation coefficient or they want you to use it, they're either going to give it to you as a value and you need to interpret it, or they're going to allow you to use technology to calculate it. Okay? And there's a really big reason why they use technology to let you calculate it. Okay? That's how you find R. I would, yeah. Might as well write it down, take a few minutes here. Because I'll actually show you on a calculator how you could speed up this process of calculating it. But boy, one little variable out of place and then it's done. Now, if they wanted you to do it by hand, or somewhat by hand, they could definitely give you the formula, right? And I'll kind of show you again how you could attempt this. I think last year we went through all this big calculation and I had to measure, how important was it to do one of these by hand. And at this point, I don't think it's that important. Okay? We have some other studying to do at this point. I think it's more important that we can actually apply these values. And maybe even more important is that it's n number of pairs of data. And this is a sample, right, is R. Remember, the sample has one letter and the population has another one. The population correlation coefficient is actually, it looks kind of like a P, right? But it's actually not. It's actually the Greek letter rho. That's a new one for you. So you can probably see where the R came from. Because to the Greeks, that was kind of their R. But for us, it kind of looks like a P, right? And luckily, they didn't choose P, right? Because I think we have enough of those already in our stats, right? We've got several of them already, so I'm glad that they chose R. Okay. So again, we could go through it and do that one by hand, but I'm assuming you're okay that if I just kind of show you how you could speed up the process, and then we let the calculator just do it. I'm assuming you're okay with that? Right, I thought so. Yeah, that's a doozy. And as we go on in this chapter, I'll kind of show you visually what that's actually calculating. Okay, because there's a big word called residual that's very important. All right, whew. That was a lot to write down, huh? Everybody good? I can always come back to this one if you want to make sure you have it right. And maybe next year I'll just put that on the notes instead of having you write it down. All right, that's a lot. Right? And to sit there and explain where all that's coming from is kind of different. But you do see how they're squaring and taking the difference on the bottom. It's how's the y measured from each other and stuff like that. So you can kind of see it. And then how when you multiply them, and so you can kind of see where it's coming from on the numerator as well. Whoop. Oh, hey, that should look familiar. Calculate the correlation coefficient for the advertising expenditures and the company sales, right? That's the same table we had yesterday. Unfortunately, you probably entered that other table in your calculators, right? Oh, well. It won't take long to enter these again, right? Data given in example one from the other day. Use the table below to help in the calculation, and then what can we conclude? Well, wow, this is a lot of stuff. So what did we find yesterday with our scatter plot? What did we decide yesterday? I believe it was a positive correlation, but did we say how strong or anything like it? We said linear, so we gave it a form. We said positive, we gave it direction, but we didn't really give it strength, right? So we have to kind of decide how strong that one. But I think it was pretty good, wasn't it? I mean, it was pretty much in a line. So if we had to guess, we would say maybe strong or moderate. So let's go ahead. Now, you notice back in this formula that there's lots of things squared, x times y, and all of that stuff. But I'll let you guys enter that real quick. I already have it entered, and I have actually other stuff entered as well. But I'll let you go ahead and do that right now, and then I'll just kind of bring up that whole area. and I'll give you maybe a little, study guide into how to use the lists, right? Because they're actually pretty neat. They can save you a lot of time, right? All right. So there I have list 1 and list 2 kind of entered. And maybe I'll have it go back and forth. I'll get the formula up on this page. And I'm going to leave it up big so you can see it, though. So there you see list 1 and list 2 is your X and your Y, right? Explanatory and response. And then what I did is I kind of looked at the formula and figured out, well, what do I need? Well, I know I need X times Y and then add it all up, right? I need X added all up. I need Y added all up. I need X squared added all up. And I need Y squared added all up, correct? Because let's face it, this is just whatever that value is up on the numerator squared, right? You see the difference? Okay, so I need a lot of stuff. So I need X times Y. So what I did, and you don't have to do this, just hang on for a little second here. What I did here is I went over to list 3, and how do I tell it to take X times Y? How do I tell it to do that? Do you remember? Yeah, exactly. You go up there and you say, take list 1 times list 2, and boom, it just comes in there, right? And so that's what I did there. So there's your X and your Y, X times Y, right? And then I said, all right, what else do I need? Well, I need to sum up X. That's something I can do off to the side. That's sum up Y. I can do that. Well, I need X squared and I need Y squared, right? So what I did is I went into the calculator, and over here in L4, I said basically, why don't you take list 1 and square it? So that would be X squared, right? And then over here I said take list 2 and square. So that's your Y squared. So you see how I'm using the lists here. But again, I still have to add those all up. So would I sit there and manually add them up? You can. Okay, but that would take a lot of time, right? Basically, do you agree, based on our formula, I need to add all of these columns. I need all of them at one point or another in the formula. And so probably the quickest way to do that is actually right above stat, there is something that actually is lists. Okay, and that'll allow you, and if you want to, you can go in there and see what's there. It'll allow you to call up any list you want if you forgot how to do it on the keyboard here. Or you can go over to the math and do all of these things to the list. Okay, that's pretty nice. Well, min and max, I'm hoping you could kind of find that one on your own, right? But the mean, that could be helpful, right? The median, oh, sum. That's one is where you're going to make things a lot easier for you. So you take the sum, whoops, you got to quit out of there. Go into the list, and I'm going to go over to sum. So sum of what? And you pick whichever one you want to add up. So which one? The last one was pretty big, right? List 5 would have taken forever to do by hand. So then you just say, oh, well, why don't you add up list 5 for me? And there it is. It just took that whole list and added them up. Okay, so it's neat what this can do, but even quicker. So then we would do all that formula, right? We'd find all these values, we'd plug it in, and then we'd get an answer, correct? That takes a lot of time. Let's do it a slightly different way. Now, one thing that you have to make sure, and I think for most of them it defaults that way, but I don't think it does for all. You have to make sure that something that's called diagnostics is on. Because you agree that these formulas, these little programs do a lot of stuff behind the scenes, and then they just spit out answers, right? Okay, and so what we're going to do is we're going to say, I'd like to see some of that stuff that you have in the background. So you might want to write this in your notes, that you do have to, if you want to see the correlation coefficient, you do have to turn diagnostics on, okay? Because it defaults to off, because it doesn't want to have to show you so much, okay? So I think once you turn it on, I think it might stay on. We'll have to see. Okay. And to do that, probably the easiest way is to go into your catalog. I don't know if you've ever gone into the catalog, but that has every single thing that your calculator can do, basically. Every little program that you have is in the catalog, which is basically second and 0. Do you see right above 0? At least on mine, that's where it is. Is that where it is on the 83 as well? So you go second, 0, there you go, you got a catalog. Now the nice thing for me is you notice how alpha is kind of locked in. So instead of like sitting and hitting the arrow, I know I want diagnostics, right? Which starts with the letter D. So you go to whichever one has letter D on it, and then it'll take you right to that area. For me, it's the matrix, and x to the -1 has D on it. So you go to hit that. You see how it takes you to all the D's instead of sitting there and scrolling all day? And so now I still got to scroll down a little bit, though, because I got to find diagnostics. Oh, there it is. So there's diagnostics off. You can turn it off, obviously, as well. Here's diagnostics on. So just go ahead and hit enter. Well, it hasn't quite turned it on yet. You hit enter again, it's on. Okay? So now what we're going to do you can clear that off. It doesn't actually turn it off if you clear it off your screen, okay? Is now we're going to go back into stat, and we're going to calculate something. We want to know how well this correlates to a line, correct? That's what we're looking for. Now, there's actually two we could use. There's only one you see on here. Yeah, it's number 4. That means linear regression. Like how well does it regress to a line is really what it's talking about, okay? And notice, oh, hey, it gives it in slope-intercept form. How about that? But that's actually not what we're most concerned about right now. So you put in 4. Well, now I have to tell it of what? So I got to tell it some variables. I got to tell it x and y. So where's all my x values? List 1. Oh, okay, so bring up list 1. Now I got to tell it I've given you the x value. You got to say I'm done with that one. So what do? Comma, very good. And then you got to say, okay, whoops, apparently I missed it. Now you got to say, okay, here comes the y values. That's 2. Now, one thing you can do is you can also give it like a frequency list, like how often you want it to use each one. You could make a whole other list off to the side. Kind of if you were using a histogram or something like that, you could put in, oh, this one was used 10 times, this one was used 7. You could do that, but we didn't do that. We were using each one once, right? So we don't need that. That would be next if you wanted that. So right now, if you hit enter, it should take care of it for you. Well, that was way faster. So notice this, it even gives you the line that fits in there the best. See, it tells you A is 50.7, so in other words, that's our slope, right? You see how it fits into the A spot there? And B being 104-ish is our what? What's the B location there? What's that? Y-intercept. Here's R squared, that's going to be important too. But here's R right here, 0.913-ish, correct? Well, that was way faster than going through all those lists and doing that calculation, right? There's R, 0.913 we'll call it. So, in our example, R is approximately 0.913. So we know it's a positive, but we knew that already, correct? We knew positive from yesterday. We knew that was the direction. We knew the form was pretty close to linear. This is telling us how strong it is. What number do you suppose I'm comparing this to? 1. The closer you get to 1, the stronger positive correlation you have. The closer it gets to what number, the stronger negative correlation you have. -1. What if you have a 0 in your for your that's very weak. If you have a 0 correlation, that means they correlate not at all. It means you got points everywhere. They can't throw a line in there. Now, does that mean that there isn't another correlation? Maybe there's a parabola they can throw in there that's good. Maybe there's something else they can throw in there that would be really good for correlation. So this is just a linear correlation that we're talking about. So would you, if it's 0.91 and you're comparing it to 1, so we know it's a positive, that's our direction. Form, we would definitely say linear then, because this is pretty good. For strength, you would probably go with strong. This is pretty good. And what would be your reasoning behind that? I got a correlation coefficient of 0.91. It's very strong. What if you get like 0.5? That's not so good. It's still positive, right? But not very good. You get 0, you just got points everywhere, right? As far as a line is concerned. Okay? Everybody good with that? Okay. That's way faster, huh? I like that. All right. Now we're going to see the significance of the correlation between the two variables. So this is kind of back to your hypothesis testing. It doesn't go away. Okay? The test statistic is obviously the R, right? In the standardized, though, we have to basically figure out how to standardize that. And it says it's a t-test. I think I have it in here. Yep. So it says it's a t-test. That's why we have t. Well, we take R and we divide by the standard deviation of R. No way. Can't believe that. And then obviously there's the standard deviation of R right there, or the correlation coefficient. Why do you suppose it's n minus 2 degrees of freedom? Yeah, there's an x and a y, right? Each x kind of has one that has to, has to fit in there, and the y has one that kind of has to fit in there, right? And that's actually the means of x and y have to kind of fit in there fairly well. Right? That's what they're working towards. Now, I haven't seen this particular one on the AP formulas, so apparently you may not need to specifically use this one. Okay, but they might still give you other values to take a look at. So based on what we have, do I even have another page? Oh, there we go. In example 1, we used 8 pairs of data, right? We put it in there, and we found out that, oh, hey, there's R. There's approximately 0.913. At least our calculator agrees with that, right? Test the significance of this correlation coefficient. Use alpha as 0.05. What's alpha again? Really, what does it represent? The chance of a type 1 error. Very good. Okay. So, well, the first thing we got to do is maybe off to the side here, I'll give you kind of our options for null and alternate. These are all your options, and then we just have to choose which one we're going to use. So one of them, we would say, now this is the hard part, is that we're going to try and use rho. Rho kind of looks like a P, so that's kind of tricky, right? So try and make it not look like a P, or make a note that it's a rho, right? Because we're trying always to go for the parameter here, right? So just make a funny looking P or something. I don't know, however you want to do it. P, there you go. So one of them is this. One way you could do it would be like this. And they say it's a rho. So let's just talk about what this means. Because a lot of times it's the alternate that kind of tells us which way to look, right? So it's telling me to look where the rho is less than 0. So in other words, rho is, what's another way of saying that? Rho would be negative, right? And so we're always kind of looking there, and that's kind of where we want our claim, because that's what we can support, right? And so what that really means is there is a significant negative correlation. That's what that means, significant negative correlation. So then if that means a significant negative correlation, this one up here means, the null would mean that there is not a significant negative correlation, right? So not that. Okay, but is that the only way I could write a? These are just all your options of how you could write these. And then we have to pick which one we're going to use. Maybe we'll do color coding here. Well, what's another way we could go with this? Well, we know it's rho. Well, what can I do? Something different. Yeah, less than or equal to here, 0 and greater than 0. Well, what does this one mean? Again, the alternate's telling us where to look, right? So this is saying a significant positive correlation. And then the null here is saying not that, right? And there's only one more option. Yeah, right? We've got equal and not equal, right? These are basically our 3 options, right? But it's just weird with rho because we're looking at, we want it to be positive or negative. You see how this is different from the other ones? Always before it was like, is it greater than 20? Is it great? But here it's really just positive or negative. That's why I'm showing you all the options. Okay. So what does this mean? The fact that it's not 0 means that there is, meaning that it's not 0 means that there's some correlation, but we don't know what, right? So we're just going to say that there's significant correlation, right? Because do we really at that point know if it's positive or negative? No, we don't, right? So then here we're on the top, then we're saying that there's just no significant correlation at all that we can find. Okay. Which one are we going to use? It says here, you have 8 pairs. Test the significance of this correlation coefficient. Does it say to test for positive or negative correlation? Does it say to test for that? Or it just says to test its significance, correct? It doesn't say positive, negative, or anything. So which one are we going to use? The red one. Okay, because it's not saying which one it wants me to test. It wants me just to test how significant it is. So yes, we are going to use this red one. So that's the one we will use for this. So what is the, pardon the pun here, well, what's the significance of that? Why do we need to know which one to use? You know, tails. So what are we looking at here? two-tail. Very good. Okay. Well, let's go find t. T, again, is just r over the standard deviation of r, right? So what was r? Well, 0.913, right? Everybody with me on that? Over the square root of 1 minus r, that happens to be squared, over n. Well, what was n? It was 8 pairs, right? So it would be 8 minus 2. And go ahead and figure out what that ends up being. Let's make sure our calculators are working today. Anybody got? I think some of you got it. You're just checking to see if I heard a 5.48. 5.48. Are we in agreement? That's what I got. 5.48. What does that mean though? That's our standardized, right? So that's allowing us to compare this to all other samples and things like that, correct? So where do we have to look to find out what number we're comparing it to? Well, there's lots of ways you could do it. You could find out the p-value for that. But if we're at 5.48, that's a pretty small probability, correct? Even for, now if it was chi-squared, that'd be different. But this is t, correct? And so 5.48 is out there quite a ways. Okay. So we could be pretty clear, but let's make sure that you can look it up again. We're talking two tails. So why don't you go find the critical, just to make sure, a nice little review. Find the critical t-square on that one. Alpha of 0.05, and then there's one more bit of information that you'll need to use your t-table, degrees of freedom. Yeah. And the fact that it's two-tailed. .447, and it would really be positive and negative, right? But let's face it, we know we're only looking at the positive one for this one. So what does that mean, though? Here's our cutoff of 2.447. We're over here somewhere, right? We're off in the very small tips of that tail, right? And so reject null, but what does that mean? We'll reject the null. We're saying the alternate would be supported, and the alternate is that there is a significant correlation. Okay, but I think we kind of knew that. So was there any surprise that this was pretty far out there? Because 0.91, that's pretty good, right? And that's pretty solid. Okay. So there should have been no surprise of that. So we would say, you know, at 5% significance, there's enough evidence to conclude significant correlation between advertising expenditures and company sales. So in other words, it's positive even, right? So the more, really what that means is the more they would advertise, the more they should see in return. Please realize that there has to be a leveling off period with that. You can only spend so much and still get a good return on it. Okay. Any questions on that? A lot of times, yeah, you'd like to, or unless they're asking you to show that there is no significance, then you would, you know, your claim would still be, because that could be asked. It depends on what you're trying to do. That's a good question. And you learned a new Greek letter today, rho. Any questions? So what are the three, about association, what are the three main aspects? Strength, direction, form. A lot of times, which form are we going to be looking at? We're going to try for linear, but if it's not, then just say it's not, or it's curved, okay? Or it's everywhere. Talk about it in some way, shape, or form.